Morning, ladies and gentlemen. Welcome to section 2.3, proportions and measurements. This section may or may not be one of the more challenging sections we've done so far, so it's very crucial that you take some notes and ask questions of myself when you can and need to. Okay, so we're going to start off. Here's some vocabulary that you need to know. We'll be talking today. It's all about changing the units that we have into units that we know, or into something else by using information that we know. So that's going to be using conversion factors and then this idea of dimensional analysis. Okay, so here's the idea of conversion factors, and when we talk about this is kind of work that'll be like, well, duh, but it's one of those things that we need to make sure we go over. All right, so the first question is how many minutes are there in a 24-hour day? So when we set this up, we're going to set this up like we've got proportions. So we've got a 24 hours, and so we've got 24 hours, and that is over one day. And so what we're going to be looking for is our final answer. We want to have minutes in one day. Okay, so what we're going to do here is we're going to use something that we know, and in this case we know how many minutes there are in an hour. So we know that in 1 hour there is 60 minutes. Okay, so what that means is when we do these equal signs essentially turn into multiplication problems. Okay, so we've got 24 hours over one day times 60 minutes over 1 hour, and that's equal to how many minutes there are in a day. This last equal sign stays because this is our final answer. So that's what we're looking for. Okay, now what happens here is when we set up these equations, we have labels here. When labels are diagonal from each other, so we've got hours and hours down here. When they're diagonal from each other, they go away. So they're gone. So now hours is out of our problem. So all we're left with is 60 minutes, or all we're left over with is minutes and day. Okay, so what we've got here is we've got 24 times 60 minutes, and that is over 1 hour. So what we do to find our answer is we take 24 times 60, and we get an answer of 1,440. So that means we have 1,440 minutes per day. So that would be our final answer, 1,440. It's a terrible looking stuff we've got there. Okay, 1,140 minutes per day. Okay, so now we're going to go through this next one a little bit quicker. We have how many feet are there in 34 yards? So we know that we're given 34 yards, not yads, but yards. And what we know, or what we're trying to find out, is how many feet we have. Okay, so with this, we have just 34 yards. We don't have anything to go on the bottom, but that still doesn't mean we can't use the idea of equations here. So this basically means this is just over 1. So if yards is up here in the top, that means yards has to go down here in the bottom. And what we're looking for is feet. That goes up here on top. So how many feet are there in 1 yard? Well, hopefully everyone is saying 3. So that means we have 34 yards is equal to 3 feet over 1 yard. That changes this to multiplication. And when we take 34 times 3, we get an answer of 102 feet would be our final answer. I just take 34 times 3 I don't have anything else to divide by down here in the bottom because it's just by 1. So yards went away. We end up with 102 feet. Okay, so now those are conversion factors. They're one-step problems to get to our final answer. But now the next thing we're going to go over is dimensional analysis. Dimensional analysis uses more than one step. So we got that same type of problem that we started off with. We've got 24 hours in one day. But now I'm trying to figure out how many minutes or how many seconds there are. Okay, so what we're going to do is we're going to use the same principle that we just had. I know that 1 day or 1 hour is going to be 60 minutes. We had that from before. Okay, but we're looking for seconds. So that means I have to do the same type of deal. I'm going to create little railroad tracks to help keep my answers good. I've got 1 minute is the same thing as 60 seconds. Okay, so what we've done here is we've now linked up more than one conversion factor together, and that's dimensional analysis. So I've got start with hours, and I put hours on the bottom, so hours goes away. I know I need to keep day because that's what I'm looking for, is how many seconds there are in a day, so I'm keeping this, but I need to get from minutes to seconds. So I put minutes down on the bottom, so minutes go away and we end up with seconds. So that means we just take 24 times 60 times 60, and that equals how many seconds there are in a day. And when we do 24 times 60 times 60, we get an answer of 8,640. So 86,400 seconds in a day. And this is our final answer. Okay, so we used different conversions there. Okay, so now we're looking at the toughest problem here. Cheetah runs 30 miles per hour. What's its speed in feet per second? Okay, so we've got, I'm starting with miles. That per means division. We've got hour. So if you're looking at this, what we need to do is we need to change this so that our final answer says feet per second. Okay, so if you look at this, we now have miles an hour. Both of these now have to change so that we end up with feet per second. And so our final answer, we want feet per second. Okay, so what we need to do is we need to get rid of both of these using conversion factors that we know. So I'm going to start with getting rid of miles and getting it into feet right away. So that means I've got miles will go on the bottom, and I can convert miles to feet by using information that I know. And if you don't know how many feet there are in a mile, watch the movie Remember the Titans and watch the scene where Petey fumbles the football in camp. Okay, and they tell you how many feet there are in a mile in that one. Okay, so that gets rid of miles for us and gets us to feet where we need to be, so we are now good. Okay, so feet is locked in place. I am good there. So now I need to get rid of hours and change it to seconds. We just kind of did this, except we had it in reverse order. So now hour is going to go on top, and then we go from hour to minutes first. So I got rid of my hours, and then I put minutes on top and put in seconds on bottom. So that gets rid of my minutes. And if you look at what variables are gone and what variables are left over, we end up with feet and second. So that's the work we're going to be using to go through. So now we just plug in the numbers that we know. Okay, so we've got 30 miles per hour. So I got 30 miles over 1 hour. Okay, so now we're looking through, I need to know how many feet there are in 1 mile. And because of Petey, I know that there are 5,280 feet in 1 mile. Okay, so we got rid of our miles here. So now we're looking, the next one was hours over minutes. So in 1 hour, we have 60 minutes. So now hours is gone. And then we go 1 minute is 60 seconds. So now minutes is gone, and what we're left over with is feet per second. Okay, and if you look here, we've got numbers on the top, we've got numbers on the bottom. So this looks like a, this is exactly like a fraction. So we're going to multiply the tops and then divide by the bottoms. So we're going to multiply these numbers together, multiply these numbers together, and then it turns into a division problem. So we're going to take 30 times 5,280, which gives us 1,000 or 158,400. We're going to divide that by, we take 60 times 60, which is 3,600. So now we divide that. Okay, so this was, we're multiplying all these together. And when we divide that, we end up with 44 is our answer. So that's 44 feet per second. And here is your try on your own problem. Please make sure you're getting this down into your notebook and into your notes, and then make sure you are writing out your summaries as well. And have a good day.